Yes, is this audible? Fahad, are you able to hear? Abia?
Yes, ma'am.
Yes, ma'am.
Now I was just checking whether it's audible or not, Abia. Now see, we are starting with this lesson, current electricity. This is chapter number 3 of your NCERT. Chapter number 2, we have completed it. So chapter 2 was completed. Now we are beginning with chapter number 3. So chapter number 3, current electricity, the way when we did electrostatics, what was the basic quantity that included? The basic quantity was basically your electric charge. So electric charge ultimately constituted your whole lesson. Now with the help of all the electric charge that are present, we'll be having electric current. Now electric current is basically, it is related to electric charge only. Who is this? Sayyida Rufia? Sayyida Rufia?
Yes, ma'am.
Yes, what's your name?
Sayyida Rufia.
You are new into this batch.
Yes, I actually changed my timing, so I came in this batch.
Okay, fine. So you were already attending the classes. So
Yes.
which chapter was completed in your batch?
No, actually, 3 days I was absent because I was shifting my house, so I actually don't know what they're doing.
Last class which you attended?
First, we were doing capacitors.
Capacitors.
Topic.
Who was teaching you?
First, it was Adil sir, and then now it was Talha sir.
All right, I got it. Fine. So you must be doing capacitors and has switch. All right, fine. So whichever portion you are left, no, you are left with, you can get added on the WhatsApp group. Then those lessons you can take the recording as well, and freshly you can start from here. Current electricity. This is your chapter number 3 of NCERT. Fine.
Okay, ma'am.
All right. So now see, as I was telling, the basic quantity that was discussed was electric charge. Electric charge, we have studied that it's the basic property and it's the fundamental quantity. Now, with the help of electric charge, we can define other quantity, which is a derived quantity. Now, electric current is basically what? Electric current is the flow of charges. If I take a cross-sectional area, let's say I have taken a cross-sectional area. This is a wire and I am considering its cross-sectional area and charges are flowing. Q is the amount of charges that are flowing. So whatever is the rate of flow of these charges, see, as I have mentioned you people earlier when we were doing chapter number 2 as well, when anything gets divided by time, we call it as rate of flow. Like if you people have done it in your 11th standard, rate of flow of displacement, rate of change of displacement, that is known as what? Velocity. Rate of change of velocity, that is known as what? Acceleration. So what is the formula of velocity? Distance divided by time. Any quantity that gets divided by time, we call it as rate. So here as well, in case of electric current as well, electric current is basically rate of flow of charges. So from the term rate only you can conclude what is electric current. Electric current means rate of flow of charges. That is how much charge is flowing in 1 second. If I start the timer at t is equal to 0 and I allow the charges to flow, then at t is equal to 1 second, I stop the timer. Whatever is the amount of charges that are flowing within this span, we call this as an electric current. So formula of electric current becomes easier to calculate. Charge divided by time. And the simple definition of electric current is rate of flow of charges. So formula will become change in the flow of charge, means whatever charge has flown by the change in time that has occurred. So rate of flow of charge, basically delta Q divided by delta P. This delta sign we always use whenever there is a small change. So this will give us average current. Average current means what? Average current means, for example, if I'm asking you to calculate the current between two time intervals, let's say between t is equal to 3 seconds to t is equal to 4 seconds, tell me the current. So whenever time interval is given, then you have to use this formula, delta q divided by delta t. This is when time interval is given. Do you understand the term interval? Interval means when you have two times given and you have to calculate the whatever is the physical quantity within this time span. So current is what? Current is rate of flow of charge. Formula will simply be I is equal to Q by T. If you have average time given and you want to calculate the average current, use this formula I is equal to delta Q divided by delta T. What if I am asking you calculate the current at t is equal to 3 seconds? Or what if I'm asking you to calculate current at 3.0008 seconds? Some specific time I have mentioned, you like calculate the current at this specific time. Not the interval. Interval, we know delta Q means you can calculate the difference in the charges, you can calculate the difference in time, you can take the ratio that will give you the current. But when I am asking you to calculate the current at a specific time, and that can be very, very small. It can either be t is equal to any big whole number like 4 seconds, 5 seconds, 100 seconds, or it can be very small number, infinitesimally small, which we call, where we use d, 0.0005 seconds. So at such instance, when we have to calculate, instead of taking the average, when we have to calculate the instant value, we differentiate charge with respect to time. As I told you people in the beginning of the chapter 2 only, whenever we'll be dealing with this anything that is instant or anything, we will be utilizing differentiation throughout. So differentiation is not only just used in your mechanics in 11, throughout it will be used. The way we had seen, integration was used so much in potential lesson. So current is what? This is differentiating charge and time. Differentiating charge and time. That gives you instantaneous current at a specific time. This gives instantaneous current. Means at a specific time. So for average current, you have delta Q by delta T. For instantaneous current, you have dQ over dt. You will be able to understand it. If you have non-uniform, you can use dQ over dt. If you have uniform, you can use delta Q. That will be clear, get clear with the help of question. We'll do a numerical on this. Don't worry about that. So definition of current is clear. Current is basically rate of flow of charge. Now the second part to it is what is the direction of current. So direction, few things I have written earlier only. So this you can copy later it down when I'll allow you. Right now, just understand what is the direction. See, for positive charges, if you have a positive charge, for example, I have plus Q. This is a positive charge. Let's say supposedly this positive charge is moving in this direction with v velocity. Which is this direction? Towards the right hand side, this direction. If it's a positive charge, then the direction of current is same as the direction of velocity. Basically, we say whatever is the direction of motion, or in whichever way, in whichever direction the positive charge is moving, current will be flowing in the same manner. If this is the flow of charge, then the current's direction will be also like this. But had it been a negative charges include what? Your electrons, all these charges. Your positive charges include your protons. You're just taking an example, negative charge can be anything. -4 coulomb is also a negative charge. So any negative charge is valid. But in your theory questions, if it specifically asks you for electrons, so then do consider it as a negative charge and write the points, whatever it is asked. So for example, let's say minus Q is moving in this direction with velocity v. In this direction means in the right hand side with velocity v. Now for negative charges, the direction of current is opposite to the direction of motion. So if charge is moving in this direction, current flows in the opposite direction. Whatever is the direction, just take it, reverse it for a negative charge and keep it as it is for a positive charge. So this becomes the direction of current for a negative charge. Now, two more important points you have to remember in the theory of current. Current topic, this topic is very small and it's very easy. Till Ohm's law also, even your Ohm's law is very easy. It is not tough as your Gauss law where you have to perform lots of derivations and all. Ohm's law is also simple. So these initial portions of current electricity is very simple to catch up with. Now, two more important points that you have to remember. One point that we always discuss whenever we discuss a physical quantity, that is the SI unit. So SI unit will be what? SI unit, if it is based on the name of a scientist you might have heard of, ampere. On your dimension analysis in class 11th, you must have heard of this term. The SI unit is amperes. This is the SI unit. So first point was this. Second point is that though current has a direction, it has a magnitude, but still current is a special quantity that is included under scalar physical quantities. See, physical quantities are divided into two main groups: the scalar quantities and the vector quantities. The vector quantities have the direction as well as a magnitude. The scalar quantities have only the magnitude. But regarding electric current is such a specific and a special quantity whose direction is also there and whose magnitude is also there, but it is included under scalar quantities because it doesn't obey the vector laws. Means for calculation of current, net current, you don't need to take out parallelograms law and other laws of vector to calculate your net resultant electric current. You can directly use your algebra for the calculation of net electric current. So you have to keep in mind, though it has a direction, but since it does not obey the vector laws like parallelogram law, triangle law, polygon law, and all the vector laws for calculation of direction, we categorize current under the heading of scalar quantities. So current, do remember that it has a direction, but it is a scalar quantity. So this is the very basic part of electric current. Basically, just remember it is rate of flow of charge. SI unit is coulomb per second, which is known as ampere, and it's a scalar quantity. Direction is same as that of motion for positive charge. It's opposite for a negative charge. So start writing it from here, then we'll do questions on it. one, term time interval. Time interval, Fahad, this will get clear with this. Look at this question. I think you people have written it by now. Look at this question. This says what? Charge is flowing through a cross-sectional area of a conductor that is given by 3t square plus 2t plus 1 coulomb. This much is charge going. Now you have to calculate current in 0 to 2 seconds. So this is a time interval. Second part says current at t is equal to 2 seconds. This is instantaneous current. So in the first case, you have to use the first formula, average current. And in the second one, you have to calculate the instantaneous current. First one is time interval 0 to 2 seconds. From t is equal to 0 to t is equal to 2 seconds. This time gap, this is known as time interval. And like second part says exactly at t is equal to 2 seconds, how much charge is flowing till. So there you have to differentiate. So second part I'll help with you, but first part at least try. Just try. You have to find out the change in current. So the best method to calculate such kinds of question is that first find the charge at t is equal to 0 second, put t is equal to 0, then calculate the charge at t is equal to 2 second by putting t is equal to 2. You have got the both the charges, so subtract it to get change in charge, and you know the change in time means time interval. Take the ratio, means divide it, you will get the current. So take 2 minutes, just try this question, then I'll discuss it. At least the first part all of you should try. Second part involves differentiation. So whoever gets the answer, just submit it in the chat box. And if you have any doubts, just ask me regarding electric current, because the theory portion of electric current is this much only. Now, every term that will be coming in your syllabus or in your exam, any topic, that will be related with current. So did anyone try? Let's discuss it now. I think ample time was given for it. T is equal to, whenever you get the questions for interval, see how will you do it. This is the method and this is the basic method. For every question you'll be able to. Father, are you asking something? All right. Now at t is equal to 0 second, first let us calculate the charge. So Q, just put T is equal to 0 in the whole equation which you have. So this becomes what? 0 square plus 2 into T. So it becomes 2 into 0 plus 1. So this ultimately becomes 1 coulomb. Fine. Now at T is equal to 2 seconds. Charge is what? Put T is equal to 2 seconds. So you have what? 3 into 2 square plus 2 into 2 plus 1. So this becomes 4. 4 into 3 gives 12. This is what? 12 plus 4. You have 16 and here it is 17. 17 coulombs. Now, what is the current? Current is change in charge divided by change in time. See, change in charge is what? This is initial charge. This is final charge. Final charge minus initial charge, that is 17 coulombs minus 1 coulomb divided by the time interval. Time interval is what? Change in time means initial time and final time is there. So final time minus initial time. So that becomes what? 2 minus 0. So this is basically 16 divided by 2. That gives 8 amperes. First, tell me any doubt in the first part, then we'll move on to the second part. Clear to all of you? Samya, Rufia. All right, it's clear. Fine. Rufia, is it clear to you, all the topics?
Yes, ma'am.
All right. No, final minus initial part. Whenever we calculate the change, we take the final quantity minus the initial quantity. Remember when we did loss of energy, there only we took initial minus final because we were calculating the loss of energy of capacitor. So whenever we take the loss where we have a negative sign, then we take initial minus final. Otherwise, in general, whenever you have to calculate change, take it as final minus initial. Now moving on to the second part. Second part, whenever you have to calculate current for a specific time interval. So current is given by 3t square plus 2t plus 1. This much coulombs law, 3ts. So at a specific time interval, not an interval, at a specific time moment I have to calculate. So I have to differentiate time charge with respect to time. So differentiating charge. What is the value of charge? Charge is 3t square plus 2t plus 1. This is whole term of charge. Now differentiation we have already studied. Those who do not remember it, if x is raised to the power n, then differentiation of x with respect to anything, whatever we are differentiating it, that is given by nx to the power n minus 1. This is the basic law of differentiation. So current will be equal to what? 3t square we are differentiating. 3 is a constant. This is a product of constant and a function. So polynomial function is what? T square. So just instead of x we have t, instead of n we have 2. That becomes 2 times t to the power 2 minus 1. This becomes, yes, Fahad, right answer. That is 16. This becomes 3 into 2 will come out. T to the power 2 minus 1 will be left. Plus 2 t to the power 1 is already here. Minus 1 we will do. And since 1 is a constant, this will be 0. So what is left? Here we have 60. From here, t to the power 0 is 1. So that becomes 2. Now, what is the time given to us for the second part? It's 2. Calculate time at 2 seconds. So this becomes what? At t is equal to 2 seconds, current. Just put current as 2. 6 into 2 plus 2. So current becomes what? 12, 13, 14. 14 amperes. So this is the answer for the second part, where a specific time was given and I is equal to 8 amperes is the answer for the first one. So note down this, then we'll do more questions on it. Done with the writing part. All right. Now, one more question is there. I hope you have written. If anybody is writing, just stop me or just let me know. I'm scrolling it. Now, it says an electron is revolving around a nucleus with frequency nu. The symbol is known as nu. And this will be used a lot in your modern physics. When we'll reach modern physics, you have a chapter, no, dual nature of matter. and particles. There you will be using this a lot. So an electron, it is revolving around the nucleus with this specific frequency nu. You have to find out the current, calculate the electric current. Now, does anyone know the relation between frequency and time? Anyone from the class? Nobody? Frequency and time. Any relation between them? See, frequency is basically inversely proportional or reciprocal of time. Frequency is basically 1 by time. This is the relation of frequency. 1 by t. Yes, Fahad, it is 1 by time. Time will be equal to 1 by frequency. Frequency is 1 by time. That's why apart from the unit hertz, we have the SI unit of frequency as time inverse. That is seconds inverse as well. Right now, that is not of your concern. What is frequency? What is meant by frequency? What is the SI unit? Right now, this relation is important. So if you do not remember this, then just note it down that frequency is basically reciprocal of time period. Now, we have to find out the current. So remember this relation Q is equal to NE. When we did the first lesson, electric charges and field, there we did properties of electric charge. So we had covered quantization of electric charge. There we did this Q is equal to NE. But right now, since we are not given electric charge, we have to find out electric current. Electric current is what? Current is basically charge divided by time. Time can be written as what? Time can be written as 1 by time can be written as what? Frequency. So Q, keeping Q as it is, 1 by T becomes frequency. And let's put any also if in the question supposedly, because the charge is known to you. Right now you know the charge, that it is an electron, and you also know that the charge on a single electron is 1.6 into 10 to the power minus 19 coulombs. That is known as an electronic charge, E. We had done this in the very first class only. So all those who have forgotten it, Q is equal to NE was the formula for quantization of charges, where E stood for 1.6 into 10 to the power minus 19 coulombs. So current's final formula will become what? NE into nu. This one. Yeah, so just copy down this question, copy down the solution. We'll do more things on this before moving on to Ohm's law. Yes, Abhya. See what it's saying. Frequency is basically 1 by time. And since what is the formula of electric current that we know? We know the formula of electric current as charge divided by time. So we have to substitute charge in terms of the question that is given, and we have to substitute this time. Now, I think we didn't do this together because you joined late, Apia. Are you aware of this topic, quantization of electric charge? Have you ever done this?
Yes, ma'am.
You're aware of it? That basically, in just short, I'll tell you that the electronic charge, this we have discussed, it is 1.6 into 10 to the power minus 19 coulomb. This is known as electronic charge, E. And any quantity or any value of charge for electron, this is integral multiple of it. Means for one electron, the value will be 1.6 into 10 to the power minus 19. For two electrons, it will be 2 times 1.6 into 10 to the power minus 19. For three electrons, it will be 3 times this value. For 4 electrons, it will be 4 times this value. So it is basically what? This is basically N times E. So this is quantization of charge. So why are we writing this as NE? Because electron is mentioned to us and electron is revolving. A charge is revolving has not been mentioned. An electron has been revolving is mentioned. So Q is equal to NE. So substitute it. This becomes what? Instead of charge, this becomes NE. Now NE is getting multiplied by what? 1 by time period. Yes, can we write it like this, Abia? Do you agree?
Yes, ma'am.
Yes, and 1 by time period is basically frequency. So I have just replaced 1 by time with frequency. Clear?
Yes, ma'am.
So all of you have written. Samya, I think she wrote it as. What about others? As you people complete a portion, no, just keep on writing done in the chat box so that I get an idea who all have completed the writing portion. All right. Okay, one more thing. Before moving on to drift velocity, two important graphs are there. See, if whenever this graph, whatever is the theory behind it, I'm telling you, this is valid for every topic in physics, and this will be used in Ohm's law, because in your board exam, especially, you have questions based on graphs for potential versus current graphs, especially you have it there. So understanding the concept of graph is important for your board exam as well as for your competitive exams like NEET and JEE and all the other exams. Now remember, whenever we have to find the slope of any quantity, slope of the graph, mathematics students who all have math students know this. They are doing graphs in detail. But whoever is not aware of, the slope of the graph is given by tan theta. So tan theta is taken basically what? This is perpendicular divided by the base. That is the y-axis divided by the x-axis. So if you divide two quantities, you get the third quantity by the slope or the tangent of the graph. Whenever you multiply two quantities, then you get the other quantity by the area under the graph. This is very important. This I think you must have done in your 11th when we do distance, velocity and displacement and all these things. So right now, understand this. Charge is getting divided by time. That is giving you a third quantity, current. So if you have a graph that is Q versus I graph is there. Q versus not I, Q versus T. Q versus T graph if you have. Charge versus time graph is there if you have such a graph. Then their slope will give you electric current and slope is given by tangent. That is division of charge by time. Clear? If you are asked to draw the graph between Q versus T, this is how you draw. Other thing you have is if you have current versus time graph. If you have this graph, so you also know if current is equal to charge divided by time, then current multiplied by time will obviously give you charge. So current versus time graphs is what? They are getting multiplied. What did I tell you just now? Whenever two quantities are getting multiplied, the third quantity is given by the area. If two quantities are getting divided, third quantity is given by the ratio, division. If two quantities are getting multiplied, then the third quantity is given by the area under the graph. So whatever is the area of this triangle, that basically becomes the current if you are given questions graphically. So note this down. Any out of 1 and 2 you're not able to understand, ask me again. Otherwise, just note it down. Then we'll move on to one more important question, one more important concept, that is drift velocity. Before moving on to drift velocity, get your concepts of current clear. If any doubts are there, if not, then okay, we'll move on to drift velocity. Done. Others, Samia has done. What about others? Fahad, Rufia, Abia. All right, you people have also completed. All right. Rufia, I wanted to ask one thing from you. In your school, which lesson is currently going on in physics?
Ma'am, we actually have summer vacation.
Yes. Summer vacations are going on before the commencement of summer vacation. Just what chapter ended? Which chapter?
Second chapter.
Second chapter ended. All right. This I wanted to ask. All right. Okay, so these are the two graphs that we have discussed. Now, this is very important topic, drift velocity. And the derivation of drift velocity is lengthy. So usually it doesn't come in exam to derive. It can come, drift velocity. But drift velocity questions, the drift numericals on drift velocities are ample given in your previous years for any of your papers, your competitive papers, for your CBSE board papers or any board papers. So drift velocity is a very important topic, a very basic topic. After electric current, this is the basic topic that is also mentioned in your NCERT in this sequence. Now, everything, the definition and those parts are written, so don't worry about it. At the end, I'll allow you to write it. I'll give you time to write it, sufficient time, but just understand the meaning of it. Let me read it. Yes, graphs come in board exams, Fad. Graphs do come in board exam, especially Ohm's law graph will come. Ohm's law graph, we'll do it because we haven't started with Ohm's law. But graphs, any graph comes, even in your normal 11th class half yearly exams, you people have graphs. So graphs have come in exams. Questions will come like the simplest question can be draw the graph between current this charge versus time. So you can draw a straight line graph. This can be the simplest question, and maximum to maximum it can give you in this way. I'll show you. This was the graph. No, it can give you instead of Q, it can mention you some charge. 5 coulomb is there on the y-axis, and instead of time, it will give you 5 seconds is there on this axis. Calculate the current using the graph. So how is the current given? By the ratio, it means 5 divided by 5 gives you 1 ampere. Like this, maximum to maximum, this difficulty level is there in the graphs. Graphs portion is very easy. That's why we are not doing any numerical on this, because direct formula or direct putting the values will come. Or similarly, it can be asked like, you know, this part, this is given as 2, time is given as supposedly 3 in this, and then you are asked to calculate the current. So current is given by area of the triangle. So you can directly use half into base into height, that is half into 2 into 3, that gives you 3 coulombs. Clear, Fahad? And all others also, how questions can come. Either you are asked to draw the graph simply, or you are asked to calculate charge versus time. Charge or the current. If any doubts in graph is there, you can ask again. But remember, graphs come in exam. See, for understanding drift velocity, I am taking a section of a wire, but things actually, all the mechanisms occur inside the wire. So that's why I'm drawing this wire broadly. Otherwise, this is a normal wire, like this normal thin wire where current is flowing. So just in order to understand what is drift velocity, we are taking a very broad section. We are just zooming it to understand. Now, a wire, whenever a current is flowing, consists of what things? It comprises of positively charged ions. Then it also comprises of electrons which are negatively charged. As soon as the positive terminal is connected, it attracts all the electrons. If I connect this to a positive terminal, the positive terminal will attract all the electrons. While it is attracting all the electrons, what happens is that electrons are moving in random order. They do not move, or they do not seek away from the positive ions or anything. They collide. What happens as the electrons are moving? Just look at this. For example, this electron is moving. So while moving, this electron will not only collide with this electron, it can collide with this electron, it can collide with this positive charge, it can collide with the walls of the container while motion. Because electrons move in this manner, randomly. Whenever electric field is applied, under electric field, all the electrons get attracted towards the positive terminal. So when it gets attracted towards the positive terminal, electrons move in random order. They collide not only with each other, with the walls, with the positive ion, among themselves, random order. So when this collision is happening, or whenever this motion is occurring, every electron has its own velocity. Since it is colliding, some velocity will get decreased, others electrons velocity will increase, some will be moving with constant velocity. So different velocities of electrons will exist. Let's say u1 is the velocity of this electron, u2 is the initial velocity of this electron. All these, see, initially obviously they are at rest. Final velocity we can talk about, because initially all the electrons are at rest. When we apply electric field, when we connect it to a circuit under the potential, then only electrons move. So obviously initial velocity is 0. But regarding final velocities, every electron will has its unique or different final velocity. Now, drift velocity is basically the average of all these velocities. We have to find an average velocity, with which the electrons are moving. If I ask you, tell me what is the velocity with which the electrons are moving, will you answer u1 or u2 or u3, or if any number of electrons are there, uns? You cannot choose either of these, u1, u2, un. You have to have an average velocity of all these velocities. So the average velocities of all the electrons, because of which they are drifting towards the positive terminal, that average velocity is known as drift velocity. Now the derivation is just a little lengthy, but it's easy to remember if you listen it carefully. So average thermal velocity will be what? Let's say initial velocities are u1 plus u2 up till un, n number of electrons are there. So average velocity will be u1 plus u2 plus un divided by n. Now, definition I have already written. Force. Can anyone tell who remembers relation between force, charge, and electric field? We have done it ample number of times. Force, charge, and electric field. Samya, can you try? Force, electric field, and charge. F, Q, and E. We had done this relation when we began with electric field. The definition of electric field came because of this only. F is equal to E by Q. No. E is equal to F by Q. That means F is equal to QE. Clear, Samya? F is equal to QE. All right. Now, acceleration is given by what? Force divided by mass. Force is QE. We are talking about electrons. So instead of writing Q every time, just let us write E, so that we know that it's the electronic charge. So this becomes E divided by M. This is what? This is the acceleration. All right. So drift velocity is a definition, you can write it later. This is the acceleration. Now T1, T2, these are relaxation times. What is meant by relaxation time is basically when two electrons collide. Let's say these are two electrons. They have collided. Two electrons have collided. Then when they have collided, there will be a very, very small time interval before the next collision begins. A very small time interval. For example, two electrons have collided. Now, before it collides with another electron, or it collides with a wall or positive ion or anything, there will be a very, very small time gap for which that won't appear for us, but if we calculate it in milliseconds, nanoseconds, that will be there. That small time interval is known as relaxation time. Electrons are relaxed, they are not colliding. Now T1, T2, similarly, every electron will be having its own relaxation time. So we have to have let's write the final velocities. Final velocity will be what? V1 will be U1 plus A tau 1. Tau is, we represent relaxation time with this tau, this symbol tau. Basically, it's time only. Whatever things you are aware of time, that is applicable or just valid for relaxation time. So tau 1, tau 2, these are the relaxation times. So time taken by electrons in two successive collisions is known as relaxation time. So don't get confused by the symbol tau that it was used for torque or something. Remember that the symbol is valid for the relaxation time, and all the things and the properties that you have studied for time. Time, SI unit is second, and everything. This you can use for it also. Bafia, did you go through the recordings? Did you see any of the recording? Were you able to do it? Okay, fine. If any recording is left, you can complete it today at least. Now, final velocity of second electron will be U2 plus A tau 2. Similarly, n number of electrons are there. So that becomes UN plus A tau n. Now I am calculating drift velocity. And what did I tell you? Drift velocity is basically the average velocity. So average velocity will be what? U1 plus A tau 1 means V1 plus U2 plus A tau 2, that is V2, plus up till all the values of, if you had 3 electrons, you could take U3 plus A tau 3. If you had 4 electrons, you could add U4 plus A tau 4. If you have n number of electrons, you can write it as Un plus A tau n divided by n. You can write it down. Now let's segregate U1 and acceleration and everything. Let's segregate it. So V average will be what? U1 plus U2 up till Un divided by n. Plus we can segregate, we are just segregating the terms, nothing else. We are just segregating the denominators with respect to x. Why? That you will get to know why are we doing this. But it's a part of the derivation in order to get the formula for drift velocity. So we have to manage all the steps. So this is the initial velocities, we have separated it. Now what is left? Acceleration multiplied by tau is left, no? So acceleration is same in all of them. Let's take acceleration as common. So A by n is there. What is left? Tau 1 plus tau 2 plus tau 3 up till tau n is there. Initial velocities, what did I tell you? Initial velocity is 0. Reason, electrons are initially at rest. Then we have applied electric field and I have allowed the electrons to move. No, initially all the electrons were rest before the application of current. So that's why in this derivation, we take initial velocity as 0. This becomes 0. And now tau 1 plus tau 2 and all the time, this is what? This is the average relaxation time. Tau specifically for a single electron is what? Relaxation time. And if I take relaxation times average, mean value for every electron, that becomes average relaxation time. The way, because in this drift velocity, we cannot talk about a single electron. The reason being that a single electron is not just contributing in the motion of the electric current. There are number of electric charges, number of electrons that are contributing to the flow of current. That's why we have to consider every electron in mind, and keeping every electron is not possible. We cannot write the formula and calculate the mean value. So it's better if we take the average. Average we know. So this becomes what? This becomes average relaxation time. Average relaxation time is usually denoted by this capital. This is tau average, you can write, or you can write tau. So what is the formula of drift velocity now that it has become? A multiplied by tau by now. And what was the acceleration that we had calculated from here? Remember, initially we had taken this acceleration, this. Now one more thing. Drift velocity is doing what? This is moving the electrons towards the positive charge. And we are talking about the electrons. So obviously we will add a negative sign to it. Minus E by M we will take. So let us put in this value in our derivation that we had. And why are we taking this negative sign already? That I'll tell you again. Don't worry about that. VD becomes what? This becomes EE tau divided by M. This is the formula of drift velocity. That whole thing was the derivation. Derivation, just see it once. This is a lengthy derivation, that I agree with you. But this is not very difficult to write because many things cancel and you have to take the average. So this is the formula of drift velocity. Now, why have we considered this negative sign? That we'll discuss. Yes, Far, capital E is electric field. I'm writing each term, don't worry. VD is drift velocity. E is the electronic charge. Capital E is the electric field. Tau is average relaxation time. And M, be sure about M, that M is not the mass of conductor. You can get confused if mass of conductor is mentioned. Don't use it even if mass of conductor is mentioned. No, this is the mass of electron, and mass of electron is fixed, 9.31 into 10 to the power minus 31 kgs. So don't get confused with the mass of the conductor or the mass of the electron. So this is basically the mass of the electron. Now the significance of this negative sign which I was telling you. Basically, it is the direction, it is directed opposite to the electric field. That's why we write this negative sign. And one more thing, this concept, no, this will be dealt clearly and in elaborate manner in semiconductors, because you have a topic in semiconductors and questions also come from semiconductors with this. But right now, in very short, you can, right now, for just right now, you can understand if the temperature increases, then average relaxation time decreases. And since you can see drift velocity is directly proportional to average relaxation time, so if relaxation time decreases, drift velocity will also decrease. Vice versa, if temperature somehow decreases, then tau, which is inversely proportional to temperature, that will increase, and so the drift velocity will increase. So this thing, don't worry about this, what will happen if it's a different device, or if it, for conductors, for semiconductors, for insulators, what is the effect of temperature and how does the velocity vary? You have a full section on semiconductors in your term 2 for your second book. So don't worry about it right now, just understand this portion, that is NM. So this is what this is. This was your drift velocity. So derivation, just note it down at whichever step you get stuck. Quickly ask me then and there only. It will get clear. And after this, we'll do a very short derivation that comes a lot in your exam, more than this drift velocities derivation. First, note it down, get your concepts of drift velocity clear. We'll do it. These blue lines at this end, Fahad, this one. No, these are not electric field lines. This, I was just telling that if the circuit has been connected, you can just even erase it. This I was showing that the wire has been connected, the complete wire is connected to the stem. Don't draw it. This is enough. And remember, the negative sign signifies what? Direction of drift velocity is opposite to that of electric field. That's why we have added this negative sign. So it also has a significance. But whenever you are calculating drift velocity, we always write the magnitude. So no need of specifying the negative sign. But remember, a negative sign is there in the formula. Done the writing portion? Afia, were you able to understand while writing it? Any part that you have not understood, you can ask. Or you can stay after the class. I can explain you whichever part has been missed. Just let me know, Afia.
Okay, ma'am. Ma'am, at what time this class started?
You're currently in India right now, no?
Yes, ma'am.
So 9 p.m. For
Okay.
India's timing, it is 9 p.m. IST.
Ma'am, it was given KSA timing, right? 7:30.
No, not 7:30. For KSA timing, it must be 6:30. For others, yes, others who are there, Fahad, Samia, and whoever are there, your timings you must be given 6:30, no? Yes, yes, Wafia, it's 6:30 KSA timings. Okay, so that's why in the last class also you joined late. You were aware of 7:30 KSA. No, it's 6:30 KSA. The timings of this batch is 6:30 KSA timings. And since you're in India right now, so that is 9 p.m. IST. This is the timing. Clear, Wafia?
Okay, ma'am. For me,
All
the
right.
text is like 7:30 p.m. cases. I thought
Okay.
7:30 a.m.
I don't
cases.
know why it is. That was for your trial class, even that occurred so many days. Okay, don't worry. This is the timing. All right. So whatever has been missed, either take the recording again from me. The initial portion on the, I think 1 hour was missed. Yes, 1 hour was missed. Or you can ask me right now also if there's any doubt. Now this is very important, relation between current and drift velocity. This is very important, because with the help of this we'll be able to derive resistance, resistivity, and all the terms. And in many of your papers, even for the students who had their test in your schools for current electricity, I've seen the papers. This question I have seen a lot in most of the exams, and also otherwise also in the board exams also this relation comes. Relation between current and drift velocity. So few terms I have specified. A is the area of cross section. L is the length of the conductor. This we are drawing it broadly to understand the inside portions and the mechanism. But remember, this is a wire, thin wire like this, a thin wire like this. All right. And N is number density. Number density means number of electrons per unit volume. Then Vd is the drift velocity. This is a battery has been connected. Now, time, if you remember, from this relation, speed is equal to distance by time. So time will be equal to what? Distance by speed. Similarly, time for this conductor, for an electron to begin from here and to move till here, time will be the length of the conductor becomes the distance, and the speed becomes drift velocity. Now the charge. For finding out the charge, Q is equal to NE, that we know. But right now we are aware of N as a number density. We'll not write it as small n. Let's write it as capital NE, because number density is given as small n. No, so if we'll write this as small n and that also small n. Differentiating will be difficult. So Q is equal to NE. Now N is what? N is number density. Means whatever number of electrons are passing, number density, this is number density. Number density is basically number of electrons per unit volume. That is known as number density. We'll be seeing a term in the next class, current density. So density terms comes a lot, and each term has a different meaning. Sometimes it's per unit volume, sometimes it's per unit area, sometimes it's, remember we did energy density for capacitor, their energy divided by volume was there. Similarly, here we have number of electrons divided by volume. This is number of electrons, this is volume. So small n will become what? Small n from this becomes n into capital V. So small n, that becomes n into capital V. So we have to substitute capital N. Capital N becomes what? Small n into V. From here, you can see small n gets multiplied by capital V. Oh, no, not small n. This I have written opposite. This is the relation. Now volume also we can substitute. So this becomes N into capital V into E. Volume is always given by area multiplied by thickness. That's how we write. And wires are usually cylindrical. Like these wires, if you see, these are what? These are usually cylindrical. So area of a cylinder or volume of a cylinder is given by area of the cylinder multiplied by the length. So volume is equal to area into length. Volume is area into length. So this can be written as N into AL into E. So we have electric charge. Now let's write the formula of current. Current is what? Current is charge divided by time. You have value of charge. This is, let's say this is second equation, this is third equation, and this was the first equation. So put 1, 2 into 3, value of time into value and value of current in this formula. Put 1, 2 into 3. So current becomes what? Charge is NEAL. Time was L divided by VD. So length gets cancelled. What is the formula that you have? I is equal to NEA VD. This is the formula that you have. I is equal to NEA VD. Every term has already been mentioned, so I'm not writing it again, but repeating for you. N is number density, E is electronic charge, A is area, VD is the drift velocity, and this is the relation. And this derivation comes a lot. Numericals also are used, and with the help of this only we'll be able to write out resistivity, resistance, and all these things. One more thing that I'll tell you here is a portion that if you look at this formula, I is equal to NEAVD, it seems that current is directly proportional to the area. Remember, current is independent of area of cross section. If this is an irregular wire given to you with area of cross section A1 and area of cross section A2. Obviously, if you look at this figure, you will say A2 is greater than A1 because this is wider, this is narrower. So you will say, since area is directly proportional to current from this formula, current 2 should be greater. But remember, current is independent of area of cross section. Even this end is wider. Current I1 will still be equal to I2. And drift velocity is inversely proportional to area from this formula. You can see So if A2 is greater than A1, VD1 will be greater than drift velocity 2. Just inverse, because they are inversely proportional. So these are the basic theory portions. Just note it down. This is important and mark this as important. This can come in your even school exams, half yearlies and all. The last part says, Fahad, see, the last part says what? Current, if you look at this formula, I is equal to NEAVD. What does it look like? Current is seeming directly proportional to area. Current is seeming directly proportional to number density, electronic charge, area and drift velocity. But in reality, current does not depend on area of cross section, because obviously the amount of charges that will enter, that only will flow out. Even if you widen the area or increase the diameter, that won't affect the charges that is contained within them. That's why current is independent of area of cross section. Whatever amount of charges enter it from one end, that only exit from the other end. So even if A2 is greater than A1, means A2 has a wider base than A1, we say current at both the ends, I1 and I2, is same. But regarding drift velocity from the formula you can see, drift velocity is inversely proportional to area of cross section. So if drift velocity is inversely proportional to area of cross section, Then we use the normal law. Like if A2 is greater than A1, at the wider end, there will be lesser drift velocity. At the narrower end, where area is left, drift velocity will be greater because both are inversely proportional to each other. So since A2 is greater than A1, VD1 becomes greater than VD. Now is this clear? Any doubts till now? Others as well? Have you completed writing part? Others and everyone. Just text me done in the chat box as soon as you'll complete. Samia, Avia, Wafia is done. What about Rufia and Fahad? All right, class. So I'm stopping here today. Just revise these basic terms of current, electricity, and come. We'll begin with Ohm's law and all the important things, resistance, resistivity, that we'll cover in the next class on Thursday. So 6:30 time KSA. All right. Okay. Take care. Allah Hafiz. Bye bye.
Thank you.